Right. Good evening, everyone. So today we want to do some pure maths, unit 1, multiple choice questions. My name is Miss Nalini and I'm a teacher at the Student Hub. So today we want to try to get 45 multiple choice questions done. As always, I just want to make sure everybody is aware of how paper 1 is constructed. So you have an hour and a half to do 45 questions. 15 from module 1, 15 from module 2, and 15 from module 3, right? So 45 questions, which constitutes 50% of your overall grade. And you are allowed to use your calculator, and you must do all the questions, right? So that is your paper 1. Right, so I'm going to start right off the bat with the first question. Feel free to ask questions in the chat, put your answer in the chat as well. Some questions might feel familiar because we looked at it last week. So for example, for this one, right, you have a rational function and you need to rationalize. You need to rationalize this function. When you rationalize this fraction, you are multiplying the numerator and the denominator by the conjugate of the denominator. So Delicia is already having her answer in the chat there. So I'm just gonna, you don't need to show working for paper 1, but you do need to write, I want the conjugate. When it says that you do paper 1, you don't need to show your working, but you do need to write a certain way that if you wanted to check over your work, you understood what you wrote down, right? So looking at the denominator, if I were to multiply something in the form a plus b multiplied by a minus b, that's a difference of 2 squares. So I get x minus y. In the numerator, I technically have a minus b all squared. So a squared will simply be x minus 2ab. I hope everybody knows what this ab I'm talking about, plus b squared, which is y. So rearranging, we get x plus y minus 2 roots of xy all over x minus y, and everybody is correct. Alicia, Abigail, hi Shelby. So this here is actually pure maths. If you did add maths, some of it will look nice to you that you understand pure maths unit 1 if you have a solid understanding of add maths. But this is pure maths questions. Very nice. Question 2, using summation notation, the series may be represented by, right? So for the series, 3 is your first term. So this is just multiple choice questions, right, Zion? Just multiple choice questions. You're asking me legal questions in the chat. This is just multiple choice. So yeah, next year you'll take a look at it. For the first term, we have 3. So when r is equal to 1, one of these summations must give me 3. So you're looking at it, working it out in your mind. If I were to substitute 1 here, I'll get negative 3. I'm going to try option B. When r is equal to 1, we will have negative 1 to the power of 1 plus 1 multiplied by 3 to the power of 1. So we have 1 by 3, which is 3, which is the first term. So the list here is correct, option B. Even if you work on this, it will not be giving you 3. Question 3. P, Q, and R are the propositions. P, it is raining. Q, the sun is shining. R, there is a rainbow. So for this question, you want to take an English statement and put it into mathematical terms. It is raining is the statement P. The symbol for and. The sun is shining is statement Q. Right, so P and Q. But there is no rainbow. So the word but, we will use an and symbol to represent that. There is no rainbow, so no R, not R. And everyone is correct with option C. Question 4. The contrapositive of this statement. If Jomo is a minor, then he is rich. So for this statement, it's a conditional statement. If P, then Q. We want the contrapositive. The contrapositive is where you change it and negate it. So change it and negate it. So if not Q, then not P. So what is the English statement for this? If he is not rich, then Jomo is not a minor. Right? Not rich, not a minor. So that's right, option C. Question 5. So this notation, everyone is aware of how you read this notation, right? This is your domain, this is your codomain. F of x is equal to 3x minus 1. Automatically, you should, in your mind, be picturing a straight line, right? 3x minus 1, it's a straight line, positive gradient, so it's sloping upwards from left to right. And I'm going to draw a little sketch. I'm just drawing a sketch for you. And it should cut the y-intercept at -1. So this is your function here. Is the function bijective, surjective, one-to-one, many-to-one? Right? Bijective means that any horizontal line or any line that is parallel to the x-axis cuts the graph exactly once. Thinking about it, all straight lines are bijective. Right? Now it is a one-to-one function, but we want the best described. Bijective means injective and surjective, right? So it's bijective. In fact, any straight line, it's bijective. Question 6, we want to recall our ln rules. Ln of x, y squared, third root of z. So we call any ln rule that when it's separated by multiplication, we could write out each one separated by addition. So we have ln x plus ln of y squared. Right, you can put a little brackets here to see it properly. Plus ln of the third root of z. This third root of z is the same thing as z to the power of a third. And the next ln rule that we're going to use is that we can take that power and put it in front of the ln. 2 ln y plus 1/3 ln z. And option D is correct. Very nice, Delicia. Everyone's good so far? Yes. Question 7. If log of 16 to the base a equals 5, then what is log of a to the base 2? So we have to use what we are given first, right? What we are given is that. That is the logarithmic form. We can take that form and put it in exponential form. This is your base. This is your power. This is your result. So a is your base. 5 is your power. 16 is your result. If I were to make a the subject, I would have to take each side and raise it to the power of 1/5. Right? 5 by 1/5 is 1. And 16 to the power of 1/5, well, 16 is the same thing as 2 to the power of 4, isn't it? So 2 to the power of 4/5, that is equal to a. Now we could substitute it inside here. And using our log rules, that 4/5 is in the power, it could go in front. So we have log 2 to the base 2, which this entire thing here is 1. So 4/5 times 1 is simply 4/5. Answer choice A is correct. Right. So we're given a cubic equation, right? The highest power of x is 3 cubic, has roots alpha, beta, and gamma. What is the value of alpha plus beta plus gamma? There's a couple of ways to do the question. Right, so it might be something different when I'm doing it on the board, but you guys know watching it and doing it are two different things. So after today, make sure to you yourself sit down with the questions and do them, and time yourself to make sure you can do it in an hour and a half. So a couple ways. This is your cubic. I could divide by 5 throughout. I'll get x cubed minus 2/5 x squared plus 4/5 x plus 3/5. Right? I divided by 5 throughout. This is in the form x cubed minus the sum of roots x squared. Let me write properly in the people board, minus the sum of roots x squared plus the product sum x minus the product, right? So if we compare this minus and minus lined up, so we don't really need to concern ourselves about the signs. The sum of roots is equal to 2/5, which is right. And you could have also, the next way of doing it would have also been to use your formula, negative b over a. So negative of negative 2/5 is positive 2/5. Right? So the answer is option D. Question 9. This is your polynomial. It is divided by x minus t. We need to find the remainder. This is in the form x minus a. So we are going to substitute t, right? We're going to substitute x as t inside here. So I'm just going to let the function be f of x. And I'm substituting t inside of the function. Wherever I see an x, I substitute t. So t times t cubed, t squared times t squared, t cubed times t. Right, so I get t to the power 4 plus t to the power 4 plus t to the power 4, right? So I get 4, I'm adding the same thing 4 times. So I get 4 times t to the power 4. Option C is correct. Right, so we're going at a very nice pace today, right? Everybody's getting more and more comfortable with the question. We have the function f of x. It is equal to 3 to the power of x. Then f inverse of x. We need to find the inverse function. So the inverse function, the first thing, there are 3 steps. The first thing that we have to do, just writing it for you guys, we're going to let y be equal to the function. So y be equal to 3 to the x. That's your first step. The second step is to interchange the variables. You're going to get, wherever you see y, you put an x. Wherever you see x, you put a y. Right? And then last step is to make y the subject. So I'll let Mr. Springer know that you guys are requesting some physics. So we have x is equal to 3 to the power of y. We need to make y the subject. So I'm just going to put 3 to the power of y is equal to x. To get that y back down from that power, I need to take logs on both sides. I'm taking logs. So I get log 3 to the power of y is equal to log of x. Using my log rules, this y could go in front of the log. And it's separated by multiplication, so when I bring it across, I now need to divide. So we have log x all over log 3. So that there is equal to your f inverse function. Log x over log 3. All right, don't be writing B. The answer is A. Yeah. So sometimes you're watching it and you got the correct answer and then you choose the wrong thing. So it's A. Yeah. Yes, the answer to this question is yes. They repeat in CSEC keep. Which of the following graphs represents the function y is equal to the mod of 3 over x? So as a pure math student, first of all, you should know what y equals 1 to the x graph looks like, right? It looks like this. Y equals 1 over x, sorry, 1 over x. So even if I have 3 over x, I just multiply it by 3. I want the modulus. Everybody, these signs, mod 3 over x. That's your modulus sign. Modulus means positive. Do I have anything below the x-axis with a modulus graph? Absolutely not, right? And this is y is equal to x squared, so no. So that's correct, option A. All right, option A, y is equal to mod of 3 over x. Question 12. The sum of the squares of the roots of this equation is, all right, this is a cubic equation. So for a cubic, we have roots, alpha, beta, and gamma. Right? Alpha, beta, and gamma. Those are your roots. We want the sum of the squares. This is the English. In mathematics, that means the squares are alpha squared, beta squared, gamma squared. Sum means to add. I want a value for this. Alpha squared plus beta squared plus gamma squared. So I need some sort of formula. You know, if it was paper 2, they would have helped us out and given us the formula and everything. But let me show you guys how you come up with it on your own. Consider alpha plus beta plus gamma all squared. Right? If I square it, I'm supposed to get the sum of squares somewhere, right? So I'm going to take alpha plus beta plus gamma and multiply it by itself. I am multiplying 3 terms by 3 terms. 3 times 3 is 9 terms. I'm supposed to get 9 terms. You're taking your time and you are distributing alpha multiplied by each of those terms, alpha squared plus alpha beta plus alpha gamma. You take beta and multiply it by each of those terms. So beta alpha and alpha beta is the same thing. Beta squared, beta gamma. You're taking gamma and multiplying it by these 3 terms. So alpha gamma, beta gamma, and gamma squared. So this is 9 terms. You have an alpha squared, beta squared, gamma squared. Just put them next to each other. You have alpha beta plus alpha beta giving you 2 alpha beta. You also have 2 alpha gamma and 2 beta gamma. Right? So if it is I were to make these 3 terms the subject of the formula, right, stay with me here. If I were to make it the subject of the formula, I just have to take this and bring it across here. So alpha plus beta plus gamma all squared. All of this will turn to minus. I could also factor out a 2 into the product sum. Right? So even if you look at your paper 2s, this is the formula you would have used to find alpha squared plus beta squared plus gamma squared. Now I need to get some values for these things. And I can do that. This is my equation. Right, so from this equation, A is 4, B is 3, C is -2, D equals 1. right? To find the sum, it's negative b over a. So b is 3, a is 4. The sum is negative 3/4, right? I'm now going to find the product sum, which is c over a. That's negative 2 over 4, which is negative a half. Right. So let's see if I could take this. Oh, I locked it. Okay. Bring it down a little bit to give me some space. I just found the sum to be negative 3/4. And I found the product sum to be negative a half. You know, this question have a little bit of length to it. So we have 9 over 16 plus 1. How much is that? 16 plus 9 is 25 over 16. Right? So your answer, this you had it a long time, answer choice D. Right? I just wanted to make sure and show you how you would have approached the question. Right? If they change up some values on you, but kept the same approach, you know how to approach the question. Right? So this is an important part of how you even got the formula to begin with. Lovely. Question 15. F of x is equal to this. What is the inverse function? So we let y be equal to ln of 1 minus 3x. Then we interchange the variables. So x is ln of 1 minus 3y. Now it's time to make y the subject. So to get rid of ln, what do we do? Well, to get rid of it, you would have to raise both sides, e to the power of e to the power of ln of 1 minus 3y, right? So e to the power of x, which is on the left-hand side, e to the power of this entire thing, which is on the right-hand side. E and ln cancels out each other, basically, right? So I get e to the x is equal to 1 minus 3y. I now take minus 3y, bring it across. Take e to the x, bring it across. So to make y the subject, I divide by 3. 1 minus e to the x divided by 3. So that there is your inverse. Option D. Niceness. Question 14. Which of the following intervals is in the domain of this function here? So for this rational function, or any function, a function is discontinuous when the denominator is equal to 0, right? So when x squared minus 9 is equal to 0, we recognize a difference of 2 squares, x minus 3 by x plus 3. So that will be when x equals 3 and when x equals negative 3. The function is discontinuous at these two values. So this here is including 3. I cannot choose it, right? Now, if you want to take a look at your numerator, you have the root of x. For unit 1, you are at the knowledge that you cannot find the root of a negative number. When you go on to unit 2, well, you will learn about that. Right? So you cannot find the root of a negative number. So should my interval include negative numbers? No. So option 2 only, which is, that's right, option B. Moving on to question 15, we want to find the value of log of 17 to the base 2 written to 4 decimal places. So we can use our calculator to do this, right? I'll just introduce how we use the change of base formula. So I want the new base to be 10, right? In your calculator, it's embedded as 10, right? In your calculator. It's understood to be 10 in your calculator. So I want your base to be 10. This 17 have to go here. And this 2 have to go here. Right? Instead of, that's how I learned off the formula. The 17 have to go here, the 2 have to go there for your new base 10. So you can just type this into your calculator now. Log of 17 divided by log of 2. And to 4 decimal places, it's 4.0875, right? Because your 6 is greater than 5, so 4.0875. Not 4, 5. Right, niceness. Right, so option D is correct. So the first 15 questions, right? Remember, you're trying to do 15 questions in half an hour. So you finish the module 1 part. Module 2 is the longer part. So you want to save some time to do part 2. That's your trigonometry, your coordinate geometry, your vectors. It kind of eats up a lot of time. So we put it in some work here now. Which of the following expressions is equivalent to this? What formula comes to mind when you see this and when you see the answer choices? The formula that you want to use for this question is the factor formulae. And this formula is in your formula sheet, right? Right, it's in your formula sheet. So what it says is that something in the form of cos A minus cos B, that, let me just remember, minus 2 sine of A plus B all over 2 sine of A minus B all over 2. Yeah, so when you look at the formula sheet, that's the formula. So cos of 60 minus cos of 45 is negative 2 sine 60 plus 45 divided by 2 sine 60 minus 45 divided by 2. So you substitute and you simplify. This will be 105 degrees over 2, 15 degrees over 2. So negative 2 sine 105 over 2 sine 15 over 2, option D. Are you saying this is food? Right, straight up use of the formula. Nice and easy, right? 1 plus cos 4 to the power of A minus sine to the power of 4 of A. When you take a look at these two terms, something should come to mind. This is a difference of 2 squares. So it's cos squared A plus sine squared A multiplied by cos squared A minus sine squared A. This should look like something. Cos squared A plus sine squared A. That is a very popular trig identity that is equal to 1. Right, so multiplying by 1 doesn't change anything. Looking at your answer choices, we could start to make a substitution for sine squared A. Sine squared A, everyone, is 1 minus cos squared A, right? So if I expand, I get minus 1 plus cos squared. 1 minus 1 is 0. Cos squared plus cos squared is equal to 2 cos squared A. Answer choice A. So the technique is to recognize that this here was a difference of 2 squares, substitutions, expanding, working it out. So you all know how proven trig identities go. Question 18 is a vectors question. Right, it's bolded, right? I hope you've seen it on your side that it's bolded. Sometimes when it's hard to see, but these things are bolded. So A is a vector, right? These are 3-dimensional vectors. OP is equal to A plus 2B and OQ is equal to 2A minus B, we need to find the dot product. First things first, I don't know you guys, this I hat, J hat, K hat thing is too long for me to write. What I like to write is the matrix form. 1, -1, we don't have a K hat, so it's understood to be 0. When you write it in matrix form, you're just looking at the numbers alone. So it's much nicer, in my opinion. It just probably will take up more space. B is -1, right? Don't forget the negatives. 2, 3. So you can drop all the I hat, J hat, K hat, and leave it to the side because you just like to see the numbers alone. Now let's work out OP. So we substitute A. I could sense this question going to be long. Right? So the first thing you want to do is take that 2 and meet everybody inside there. 2 by 3, 6, right? Don't make any mistakes with the computation. And then you add it up. 1 minus 2, 3, 6. So y'all can let me know in the chat if I go incorrect, right? Because I'm kind of rushing it there. OQ is 2A minus B. Minus -1, 2, 3. 2, -2, 0, minus -1, 2, 3. All right, so I'm subtracting. 2 minus -1 is 3. -4, -3. So that is OP and that is OQ. And now I need to find the dot product. So let me get some space here. Dotted to OQ. Dotted to 3, -4, -3. So when you find the dot product, what you are doing is multiplying the corresponding entries and adding it up. So -1 by 3 plus 3 by -4 plus 6 by -3. 6 3 yeah. -3 minus 12 minus 18. 33, -33. So the dot product is -33, which is answer choice B. Hopefully I didn't make any issues with the signs. The answers were close to each other. Right, so that is how you find dot product. Question 19, f of theta is equal to cos theta plus 3 sine theta. R is positive, theta lies within the first quadrant. F of theta can be expressed as. So looking at the answer choices, it's in the form R cos theta, you have either minus or plus alpha, right? Which one would you choose? Would you choose a minus or a plus alpha? If you recall your addition formula, you want to choose one. You want to choose the one that has a minus here, not a plus, a minus. The reason being is because when you expand, it forms up, it has a plus there, and the plus matches up. So you don't have to worry about your signs. Okay? So if I expand it using the addition formula, I hope everybody knows what I'm talking about with the addition formula. The addition formula says cos theta, cos alpha, plus sine theta, sine alpha. That is what the addition formula says. And from here, you are going to compare and equate corresponding coefficients. Right? Compare and equating the coefficients of cos theta and sine theta. The coefficient here is 1. The coefficient here is r cos alpha. The coefficient here is 3. The coefficient here is r sine alpha. So we have two equations with two unknowns. First thing we need to do is find alpha. We're going to do equation 2 divided by equation 1. The reason being is because we want sine on top of the cos. Right? So 3 divided by 1. If you get sine over cos, that gives you tan. Tan alpha is equal to 3. So alpha is tan inverse of 3, which it's a long time way. They used to say arctan. Personally, I find that's too much to write. So we write tan inverse. Right? So alpha is arctan of 3. So for it being a minus and an arctan, our answer is option A. Very nice. So today we need to do the work of finding R. But it's not hard to find R. Right? R is equal to the root of 1 squared plus 3 squared. That works out to be root 10. It's not negative, it's positive root of 10. Right? Because R has to be greater than 0. Very nice, everyone. Question 20. A curve C is given by the parametric equations. What's the Cartesian equation? So a Cartesian equation only has x and y. So we could take this one and make t the subject. So we have x minus 2 all over 3 is equal to t. And I could substitute that into the other equation. Right? So if it was a paper 2 question, you would have made sure and label it and substitute equation 3 into equation 2. Plus. So whenever you substitute, make sure and put brackets. This square, please make sure you square in both the numerator and the denominator. So 3 squared is 9. X minus 2 over 3 minus 6. Now, here in pure math, we don't like fractions. The more math you do in life, you don't like fractions. So we get rid of them by multiplying by 9 throughout. So we get 9y is equal to x minus 2, right? Hopefully, you all picked up that I wrote the wrong thing there. Right? So I multiply by 9, it gets rid of the fraction, x minus 2 all squared. If I multiply this by 9, it's multiplying the numerator by 3. Yeah, that's correct. Minus 6. And now we expand and try to make it look like one of these equations here. Right? So 3x minus 6. Oh, I did a mistake. Well, I didn't multiply by 9. So when you multiply by 9, make sure you multiply everything by 9. So y by 9 is 9y. Multiply this by 9, get rid of the fraction. Multiply this by 9, you multiply by 3. Multiply the 6 by 9. Thank you, Carl. So you're paying attention. 6 by 9. 9 by 6, 54. So minus 6 minus 54. And I can simplify further. Negative 4x plus 3x is minus x. 4 minus 6 is negative 2. Negative 2 minus 54 is negative 56. Right? So my answer is option A. Yes, option A. Good things happening. Question 21. The set of values of k for which the straight line intersects the curve with equation, so that's a quadratic, at two distinct points. So when a line intersects a quadratic at two distinct points, what does that say about the discriminant? Class, what does that say about the discriminant? Sorry, somebody type that one. Right? It says something about the discriminant. So you have a straight line and you have a quadratic. So you have y equals something, y equals something. Very nice. The discriminant is more than 0, greater than 0. The discriminant is positive. You can say it any which way you like. Right, the discriminant b squared minus 4ac is greater than 0. Lovely. So what you're going to do with the equations, you're going to equate it. And then you're going to bring everything on one side. So you have minus kx. It turns into plus 4. Right? So you have ax squared plus bx plus c. Right? Everybody seeing what I mean? That a is 1, b is negative k minus 2, and c is 4. Right, it'll be plus 4. So, right, a is 1, b is negative k minus 2, and c is 4. So now we call that the discriminant, because it intersects at two distinct points. The discriminant is greater than 0. So b squared minus 4 by 1 by 4 has to be greater than 0. So when I square that, I'll get k squared plus 4k plus 4 minus 16 is greater than 0. 4 minus 16 is negative 12. So this here forms its own quadratic, which you can now factorize in one step. K by k is k squared. 4 3 is 12, 6 2 is 12, so 6. I want 6k minus 2k. Right? 6k minus 2k is 4k. So what are my critical values? My critical values are negative 6 and positive 2. Right? Those are your critical values. So now you're going to think about your number line. On the number line, negative 6 happens first, and then the 2. And we are drawing a minimum. Right, that's your minimum parabola. And we are looking at the part of the graph that is positive, meaning above the x-axis. So how would I write down my solution set? Very nice, Felicia. The solution set, everyone. Solution set. It's the values of k that are less than negative 6 or the values of k that are greater than 2. So that would be option C. So they really snuck in a whole paper 2 question in a multiple choice. Right? K is less than negative 6 but greater than 2. That's the answer for question 21. For question 22, the curves y squared equals x plus 7 and xy is equal to 6 intersect at 3 points. We want the y coordinates. We are concerned about the y coordinates. So I'm going to take this and make x the subject. Okay? Because I'm only concerned about y. So why would I make y the subject? I want to substitute it as x. So I'm going to substitute equation 3 into equation 1. X is 6 over y. Right, so that's my substitution line. And like I said, we don't like fractions here. So I'm going to multiply throughout by y to get y cubed. Multiply by y is 6 multiplied by y is 7y. So bringing everybody on one side, I get y cubed minus 7y minus 6 is equal to 0. Now, for me to go on the factors of this and then find the roots, it's too much work. Way too much work for me to do, because you'll have to do trial and error, polynomial division. Like, who wants to do all of that? It's multiple choice. The answer is staring back at you. So we're going to try y coordinates and see if it satisfies this equation. Right? So let's try when y is negative 2. Negative 2 cubed minus 7. This is negative 8 plus 14 minus 6. This gives 0. So negative 2 is good. So you're not even going to consider option C and D, right? Negative 2 is good. We don't even need to check 3. Like, why check 3? I'm getting deja vu. I'm getting deja vu for real. Negative 101. We're gonna check it. A lot of people are saying option A, so let's check when y is negative 1. Negative 1 cubed minus 7 by negative 1 minus 6. Right, so once you do a lot of multiple choice practice, you all should be walking away with more than 40 out of 45 in your paper 1. In fact, you should be walking away with 45. You could walk away with full marks in paper 1. Try to do as many multiple choice questions as you can get your hands on. Negative 1 plus 7 minus 6 is 0. So yeah, negative 1 is there, 3 is there. Okay, option A is correct. Option A is the answer to this question. Question 23. It's a circle with center at 0, 0 and has at center 0, 0 and has a radius of 6 units. The equation of the line that is at tangent to the circle at negative 5, 4. So whenever I see a question like this, my instinct is to always draw a diagram. Just to always, make sure pure math is also about picturing what it is that the question is saying. Right? So you have 0, 0, you have a tangent. Common thing. Tangent, don't want to behave here. Right? That is my tangent. Right. The tangent to the circle at negative 5, 4. Right? And that blue line there, that is your radius, that's your normal. Nice. The radius is 6 units. So I guess they gave you the radius, if it is you wanted to use like a length formula. But we are concerned with the equation of the tangent. So I could use the 2 points and find the gradient of the normal. Gradient is equal to y2 minus y1 over x2 minus x1. So I'm going to get negative 4/5. So everyone, if my gradient of the normal is negative 4/5, what's the gradient of the tangent? What's the gradient of the tangent? The theory is that the gradients are negative reciprocals of each other. Or in other words, if you were to multiply them, you're going to get negative 1. Very nice. It's 5/4. Right? Negative, this one is already negative. Reciprocal 5/4. So seeing the chat is lighting up with 5/4. So we're going to substitute the gradient as 5/4. And not this point, that point is not on the line. This point, negative 5, 4. We're going to substitute it into what we call the point slope form. Right, this formula here. Right, that's your point slope form. So y minus y1 equals m into x minus x1. So just be careful of your signs here. And you're going to get it to be one of these things. See how close it is? See why pure maths could be, you see, you know the pure maths, but then it's the computation that might trick you. So you just be very, very careful and you practice a lot to reduce computational errors. Computation is when you make mistakes with your signs or your fractions, or like when you're multiplying and you just forget to multiply certain things, right? That's computation. So you expand 5 by 5 is 25 over 4. Bring across the minus 4, and you're going to get plus 4. So 25 over 4 plus 4. You know, sometimes the calculator is just there to just put that in. 41 over 4, right? Y is equal to 5 over 4x plus 41 over 4. We don't like fractions. You see, when you do more maths, you just don't like fractions. So 4y is equal to 5x plus 41. So bringing all the terms on one side. Yes, if I bring 4y across, I'll get negative 4y plus 41. So 5x minus 4y plus 41 is equal to 0. Right? Module 2 questions is really require the most time. Right? All right, on to question 24. The curve whose Cartesian equation is that may be represented by the parametric equations. Right? So deep breath, you are halfway there, more than halfway there. This is your Cartesian equation, and you need to get the parametric equations. This is in a certain form. Parametric equations introduce a third variable t. So this is in a certain form. Sine squared t plus cos squared t is equal to 1. Yeah? So with that, we could equate x minus 3 all squared over 16 is equal to sine squared. And you could equate this now. 1 plus 4 all squared over 9 is equal to cos squared. And looking at your answer choices, you need to make x and y the subject. So 16 is the same thing as 4 squared. And I could square root both sides and get x minus 3 over 4 is equal to sine t. Right? Getting rid of the squares by square rooting both sides. To make x the subject, it'll be x minus 3 is 4 sine t. X is equal to 3 plus 4 sine t. So that's the first equation there. 9 is the same thing as 3 squared. Right? Now remember, a lot of you all here could do this in your minds, that you don't need to do a whole bunch of writing. I'm just doing the writing so you could organize your thoughts when you're watching the session. But really and truly, if you were to do it on your own in the exam, are you going to be writing a whole bunch of things? I mean, a lot of it could happen in your mind. Some of y'all could watch this and make y the subject. Right? I'm just taking the time. 3 cos t, and then you bring the 4 across, so you get negative 4 plus 3 cos t. So option C. Is it option C? That's right, option C. Niceness. Question 25. A circle is defined as this, right? So you're given the standard form. The gradient of the normal, see normal, they should bold that word, normal to the circle at 0, 0. right? We love a diagram. The reason why I like to always draw diagrams is because you yourself need to always be thinking about what it looks like. If you were to graph it, what would it look like? The center of the circle is -2, 0. So geometrically, where would 0, 0 be? Wouldn't it be right here? And are they asking, kind of bend, are they asking for the gradient of the normal, meaning the gradient of the radius? What's the gradient of a horizontal line? 0, right? They didn't ask for tangent. This is a tangent. They asked for the gradient of the normal, which is your radius. Question 26. What's the general solution? So when it is that they give you the equation with cos of something equals cos of something, the PV is just pi over 3, right? Because it had cos on both sides. So the PV here is pi over 3. So you want to recall that the general solution for your cos, now you have to take a look at what they have here. They have 2 theta, so that's what you're going to drop down. And your general solution is 2n pi plus or minus your PV. Right? Very important that you don't write theta, you write 2 theta, whatever it was inside there. Inside there, you just drop it down here, whatever it was. And now you make theta the subject. You want theta. So divided by 2, you get n pi. Divided by 2 is the same thing as multiplying by a half. So you get pi over 6, and n has to be an integer. Yes. Option A is correct. Question 27. It's -1, -1. Equation of the tangent at the point 0, -3. Again, just draw a very tiny diagram. It won't take you long. You just draw a little circle, you draw a little tangent to get your thoughts in order. The center is -1, -1, and your tangent to the point 0, -3. So using those 2 points, I can find the gradient of the normal, can't I? Right? Gradient, very well-known formula here, just writing it down. But if you were in the exam, would you write it down? Right, so -3 minus -1. For paper 1, you don't need to write it down yet. For paper 2, yes, always write a formula. Always write your substitution line. 0 minus -1. -2 over 1. Right. So the gradient of the normal is -2. What's the gradient of the tangent? It will be the negative reciprocal, which will be the reciprocal of 2 over 1 is 1 over 2. Right? So the gradient of the tangent is a half. So if I have the gradient as a half, and that's right in this here, if I have the gradient as a half, and the point is 0, -3, that point is a special point because that point is telling you the y-intercept. The y-intercept is -3. So if I substitute it into the equation of a line, what would I get? I should get y is equal to a half x minus 3. Option D, y is equal to a half x minus 3. Question 28. So what does that symbol symbol mean when you see modulus? It means length, it means distance. So a formula should come to your mind about length of a vector. Right? Everybody knows the formula, right? X squared plus y squared plus z squared. The root of it. The root of x squared plus y squared plus z squared. That is your formula. And you want to know which vector has a length of 24 units. You are going to take your options, plug it into the formula, and see which one is going to give you the answer. Now, when you're choosing something, you're going to choose wisely, right? Wisely, right? Why would you choose such big numbers? Looking way too big, right? 24 squared is 576. Yeah, 576. So let's try option B. To see ourselves, let's try option B. All right, and using a calculator to put all of that in. Now, you yourself, would you really be putting -8? I mean, I'm just doing it for the purpose of it. But -8 squared, same thing, right? So you have the calculator and just put 8 squared. You do get 24. So yes, it's option B. You don't have units, so you just put units. 24 units, option B. Question 29. The vector A is given as this. What is the unit vector parallel to A? Right? So the symbol for that is the unit vector parallel to A, right? You're taking the vector and you're dividing it by the magnitude of A. So you're taking, we could go to the side and work out the magnitude. The magnitude will be 5 squared plus 12 squared. A lot of you all here would know your Pythagorean triples that you don't even need to work this out manually. Right, your Pythagorean triple is a 5, 12, 13. So the answer is 13. So you are taking your vector 5i hat plus 12j hat and dividing it by the magnitude of 13. Divided by 13 is the same thing. Remember, we don't like division. We change division to multiplication and invert the fraction after. Divided by 13 is the same thing as multiplying by 1 over 13. So my answer is option B. Question 30, we have a function. We need the minimum value. So we can represent this expression here as r sine of theta minus alpha, right? We are not going to do any work of finding alpha. We do not care about alpha. We do not care about whatever happens inside the brackets do not affect any y values. So it does not matter what alpha is. You see that r, that will affect the minimum and maximum values. To find r, it's the root of 8 squared plus 5 squared. Which is the root of 89, right? So, I mean, you're seeing it already that the minimum would be negative root 89 and the maximum will be positive root 89. But just to make sure I show you guys the working, if it was a paper 2 question, you would have expanded it, equate the coefficients, and got the 8 and the 5 to put in here, right? Right. So this is your expression. Root 89 sine of theta minus alpha. You want to know the minimum and maximum. Now you are starting off with a fact, right? This is a fact here, people, that the sine graph lies between 1 and -1. Everybody. The sine graph lies between 1 and -1, yeah? No matter what I put in those would not affect the y values. Those are y values. So it still remains as 1 and negative 1. However, if I were to multiply the entire function by root of 89, that will affect the y values. So this here is your min. This here is your max. So the minimum is negative root of 89, option C. All right, so everybody good with the first 30 questions? All right, some of it could be really long, so you're making sure to put the majority of time for module 2. Module 2 is have more work to do, in my opinion, right? And then lastly, questions 31 to 45 is module 3. So everybody good so far? Very nice, Alicia. So that's your differentiation, your integration, your limits. All right, question 31. Y is equal to something over something, a rational function. There's a rule you should think of when you want to find the y dx. Three x plus 1. So what rule are we thinking of? If this is in the form y is equal to u over v, we're going to be using, for differentiation, you have two rules. You have product rule and you have quotient rule, right? It's a quotient. We're going to use the quotient rule. So we're going to let u be equal to the numerator and v be equal to your denominator. So the u dx is 3. Very nice, Tabitha. So everybody, quotient rule is what we're going to use. You have to learn off the rule. It is not in your formula sheet. And I think a lot of us would have learned it off stemming from your add maths days. That's if you did add maths. The v dx equals 2. So using quotient rule, you're going to write it down. So I remember back when I was in form 5. All the way in form 5. And I could not remember the quotient rule. Even though you would have done it since form 4, I could not remember if it started off with v, the u dx, or u, the v dx. It starts off with v, everybody. The way that I remember it now is that v and v squared, v. It starts off with v, right? Minus u, the v dx. I don't know why. I can remember it. See, that's why you must do math and not read it. I used to be in the kind of habit of just like reading it. But I got out of that habit when I reached form 6. Reading math is not it. You have to do it. So you substitute v. The u dx is 3. 3x plus 1 multiplied by 2 all over your v squared. The one with the product rule, Cyan, it's separated by a plus. So you're not really concerned. It's separated by plus. Addition is commutative, but this is separated by subtraction. So once you learn off the fact that it starts off with a v, you won't forget it. You won't forget it at all anymore. So you expand. Now be careful here. It's minus 1 multiplied by 2, which is negative 2. The 6x and the negative 6x goes away. 3 minus 2 is 1. So 1 over 2x plus 1 squared. So option B. Question 32. If tan, what do I get? Right? Now this is in the form tan of ax plus b. Right? So when I differentiate tan, you're going to get sec squared. But because you have ax plus b, when you differentiate it, you're going to get a sec squared, and you put back the brackets. Right? It depends on how you learn it off. Technically, you are differentiating inside the brackets. So when you differentiate inside the brackets, you'll get 5. Goes to sec squared, and you put back the bracket. So 5 sec squared 5x, which is option B. Y is equal to 4, y is equal to this. We need to find the second derivative. That means you're going to differentiate twice. So you bring down the power, 4 is 12 minus 1 from the power. Differentiating sign gives you cos. But this is 6x. So when I differentiate that, I'll get 6. Sine goes to cos, put back the brackets. Now you differentiate again. 2 by 12 is 24x. Leave the 18 alone. Cos is going to go to negative sign. Differentiate inside the brackets, you're going to get 6. Right? So you differentiate inside the brackets, you get 6. Cos goes to negative sign 6x. So we have 24x. 18 by 6. Look at the answer choices. I think that's 108. A negative and a negative makes a positive. So positive 108 sine 6x. That's right. Option D is correct. Question 34. A diagonal plane preparing for landing registers this number here, where h is the height above the ground. Just as the plane lands, the diagonal reads. Right, so you have a plane in the air, and it's approaching the ground, meaning that h is tending to 0. Right? The plane is landing. This is best as I could draw a plane for you guys right now. The plane is landing, so h is tending to 0. And yeah, we will have to recall the use of our special limit with sine h over h. So the limit as h tends to 0, because the height is tending to 0, of 200 plus 5 sine h over h. So everybody here knows their limit rules. The limit rule says I could find the limit of 200, and then I could find the limit of this. The limit rules also say I could put that 5 in front of the limit. This here is what we call the special limit. And what is that equal to? This special limit is equal to something. What is the limit of a constant? The limit, that's right, Google user. It's 1, that's right, Tabitha, it's 1, right? And the limit of a constant, right? We can't substitute h into anything here. The limit of a constant is the constant. And the limit of this thing, special, is 1. So we have 200 plus 5, which is 205. Answer choice B. The displacement S meters of a marble moving along a board at time t minutes is given by this. For what value of t is the displacement of the marble increasing? Now, first of all, right, you see the topic kinematics. That is a unit 2 topic. Kinematics is unit 2. But they just have a worded question here, right? So the displacement S of t is this. Plus 7. So what we want to do is differentiate, and we're going to get 12t squared minus 60t plus 72. And we want for which it is increasing, meaning the gradient is positive. And when you differentiate, let's say this is dy dx, for which is increasing, the gradient dy dx is positive, meaning greater than 0. So 12t squared minus 6t plus 72, positive means greater than 0. These numbers all have a factor of 12. So I'm going to divide by 12 to make my life easier. And now I have a quadratic that I can factorize in one step. -3, -2. Right? So my critical values are 3 and 2. So if you were to consider the number line, draw a parabola for you guys as the best parabola right now. Because I find out to be sitting sideways. Okay, look straight on the board. On the number line, 2 happens first and then the 3. Okay, everyone, 2 happens first and then the 3. I want the values, it's a minimum because the value of A is positive 1. And I'm looking at the part of the graph that is greater than 0, meaning above the x-axis. So if I were to write down the solution set, it's the values of t that are less than 2 or values of t that are greater than 3. Option D. Right? Less than 2, greater than 3. Nice. Next. Question 36. We want to find the limit as x tends to 0 of this. Now, in order for us to use our special limit, the coefficient of x must match up. It have a 3 here and a 2 here. It's not matching up. What to do? What to do? I'm going to make it match up. I want a 3 in the denominator. Right? I want a 3 in the denominator. I can just divide by 3. That is mad people thing. I have to multiply and divide by 3 to balance it all off. Right? Reason being is that 3 divided by 3 is 1. Multiplying by 1 does not change or break the laws of mathematics. Right? So I'm multiplying and dividing by 3. I'm multiplying by 1, basically. So this 3, I am going to put it outside of the limit. This 2, I put outside the limit. Now remember, it's division by 2. Right? It's in the denominator, so you have to leave it in the denominator. So what am I left with? I'm left with sine 3x, and this 3 comes here now. Everything is being multiplied. 2 multiplied by x by 3. Right? So this 3 came in front of the limit. This 2 came in front of the limit. And this got kept behind. So this here is your special limit, which is equal to 1. Right? As long as the coefficients here match up, that entire special limit is equal to 1. So we have 3 over 2, which is option C. Niceness. Question 37. A curve C is given by these 2 parametric equations. What is the Cartesian? So if I were to make sine theta the subject, it will be x over 4 is equal to sine theta. Y divided by 3 is equal to cos theta. And I'm going to recall my very popular trig identity. Sine squared plus cos squared is equal to 1. So substituting, it is x over 4 squared, all squared, right, put your brackets, y over 3, all squared. So when I square it, I'll get x squared over 16 plus y squared over 9 is equal to 1. I don't like fractions out here anymore, so I'm going to multiply by the, after being a math teacher for so long, I guess I should know 16 by 9 by heart. It's 144. 9x squared plus 16y squared is equal to 144. Option C. Question 38. Given that y prime, this is another way of writing dy dx, is equal to this, what is y? Right? Y prime, we don't really like to use that. We like to use dy dx. Right, so how do I get y? What must I do? I need to work my way backwards. So the opposite of differentiation is integration. So I need to integrate dy dx with respect to x, right? So your mind now needs to switch to integration. So if I integrate cos x, right, I'm integrating it. So the way that I remember it, I just remember that differentiating cos is negative sign. So integrating cos is positive sin x. Put down the minus. Integrating sign gives negative cos, but you have a coefficient of x here. When you're integrating, it's actually 1 over the 2. Do not forget your plus c, your arbitrary constant, plus c. Right? So, however you remembered, make sure that you switch your mind now to integration. When I integrate cos, I get positive sign. When I integrate sine, I get negative cos, but I have, integral of sine is negative cos. It's negative 1 over a. So negative a half cos 2x. All right. A minus and a minus make a plus. So sine x plus a half cos 2x plus c. Oh, I put the half cos 2x in front. Okay. So option B. Right. So if it is that, your mind always with differentiation, if you were to differentiate this, you'll get negative sine 2x. Differential of sine is cos plus cos x. Right. Question 39. Right. This is all special integrals. Right. So this is a learn off that if you integrate something in the form a to the power of x with respect to x, it's a to the x all over ln of a. Right? So you can mark that down, learn it off. Integral of a to the x with respect to x. It's simply a to the x all over ln a plus c. So if I were to apply it to this question, integral of 3 to the power of x with respect to x, it will be 3 to the power of x ln of 3 plus c. It's option B. Question 40, for which of the following values of x is the function discontinuous? A function is discontinuous when the denominator is equal to 0. So when x plus 5 by x plus 3 is equal to 0. So that happens when either x is -5 or x is -3. Option E. Question 41, we need to integrate this expression. Now, if you're thinking to take the approach of expansion, that's doing too much work. Absolutely not. We're not doing no expansion here. What's the technique with this question? If it was a paper 2 question, they would have told you by using a substitution, etc., integrate this. Right? So in paper 2, they do tell you to use integration by substitution. They didn't tell you here, but it's implied that you're going to use integration by substitution, and your substitution is whatever is in the brackets. So let u be equal to whatever is in the brackets. The u dx is equal to 2x. So making the x the subject. Right, if everybody understands this, the u all over 2x. You would have done enough questions where you could just write this down. Right? I don't need to do the whole. Everybody good, right? The u over 2x. Right. I'm now going to replace everything that is an x. I'm going to now replace it in terms of u. Leave the x alone. You know, certain things will happen. Leave the x alone. This is u to the power 4, and dx is being replaced by this. So the certain things happen where the x's cancel. You see constant? You're going to throw it outside. That is a division by 2x. Division by 2. Dividing by 2 is the same thing as multiplying by a half. So the constant that gets thrown outside is a half. So integral of u to the power 4, I add 1 to the power, and I divide by the new power. Don't forget your plus c. Do I ever leave my answer like this? In terms of u? Absolutely not. I put it back, right? So 2 by 5 is 10. U was x squared plus 3 to the power of 5. Right? So 1/10 into x squared plus 3 to the power of 5 plus c. Right? So don't forget that you had a 2 here, right? To consider. Yeah, you had a 2 here to consider. So 2 by the 5 gave you it gave you 1 over 10. Right? So that's the answer there. They make sure to watch out for that. It would have been 1/10. Option D. Question 42. If the rate of change of y with respect to x. Everybody, this is the English. What is that in mathematical terms? The rate of change of y with respect to x. With respect to x means rate of change of y. It's dy dx. You see what this expression they gave you here? That is dy dx. The rate of change of y with respect to x. So they gave you dy dx. And you need to work out what y is. Very nice. Yes, this is dy dx. So just putting this in the numerator, it's 4x to the -3. So to find y, I need to integrate dy dx with respect to x. So to integrate, right, your mind, remember you're being tested under exam conditions, you might have to switch between topics. That's why you have to do a lot of practice so you're able to take it on mentally. You add 1 to the power, divide by the new power. If I add 1 to -3, please don't write -4, please write -2. -3 add 1 is -2. Divide by the new power, -2, plus your arbitrary constant, c. So you get x cubed, a negative and a positive make a negative. 4 divided by 2 is 2. And looking at the answer choices, I could put that x to the negative 2 in denominator to give x squared. Right? So x cubed minus 2 over x squared plus c. Answer choice C. Very nice, very nice. Question 43. Now we have 7:30 at the hour and a half, right? But think about it, if I wasn't talking so much, you would have totally finished by an hour and a half. The portion of the curve y equals 2x between x equals a and x equals b is rotated 360 degrees about the x-axis. So because it's about the x-axis, you need x limits, which they gave you. The volume V of the solid generated is best represented as, so this is your formula. Pi, don't forget your pi, integral between a and b of, with respect to x, y squared with respect to x. Right? This is your formula here about the x-axis. We need something for y squared. We're given that y is equal to 2x. So y squared is 2x all squared, which is 4x squared. So substituting integral of 4x squared. So based on the answer choices, I could put the 4 outside. I could put the pi inside. And the constants can move. So my answer is option D. It must be with respect to x, because you rotated it above the x-axis. A and B have to be x limits. Question 44, you are given h of x. What is h prime of x? So I hope everybody here knows the shortened form of the chain rule. You drop down the power. You differentiate inside the brackets. So that's 4x cubed. You put it back and you minus 1 from the power. So you get 12x cubed, x to the power 4 plus 2 squared. Answer choice C. And the very last question for today, everyone, I need to differentiate tan squared of 3x. Right? This is your expression, which you can represent it as tan 3x all squared. Right? If I put the square here or the square there, same thing. I need to differentiate this. I differentiate it with respect to x. You are going to use the shortened form of the chain rule, and this is how it goes. You drop down the power. You differentiate inside the bracket. If I differentiate tan, I'll get sec squared. Now you have a bracket here. If I differentiate tan 3x, it's actually 3 sec squared 3x. Put it back and you minus 1 from the power. So 2 minus 1 is 1. So I hope everybody's good there. So you don't have to use no long chain rule. This is the shortened form of the chain rule. 2 by 3 is 6. Sec squared 3x tan 3x. They put the tan first. So 6 tan 3x sec squared 3x. So answer choice 8. So everyone, that was 45 questions in an hour and 35 minutes. But you could have totally done this in an hour and a half. You take your time. Like I said, you don't need to write as much. It is paper 1. So they only concerned about your answers. Right? And you just go forth and you do very, very well. Do as many questions as you can. No problem at all, Abigail. So I hope you guys benefited from the multiple choice sessions. I'm wishing you all the best in your paper 1. And make sure that you do your best in your exam. be calm under the time limit, and you just work your way forward with the questions. So thank you all for coming on today. I know today was a holiday. I didn't even remember. So no problem at all, Shelby. Enjoy the rest of your night, everyone. And if you have any questions, whilst you're studying, please feel free to message me. Bye, everyone. Enjoy the rest of your night.